Thank you. Thank you very much, and welcome to our talk. I'm David Melamed, the co-founder and the CTO at JIT. JIT is an open DevSecOps orchestration platform, and I'm really thrilled to be here and share the stage with you, Luke.
Cool. Hey, everyone. My name is Luke. I'm the founder and the chief product officer of Semgrep. I started my career as a software engineer before moving to developer tooling, before moving to security. So that's been my path, and I'm excited to chat with y'all.
So first of all, a little disclaimer that what we'll show here are only suggestions. They are based on our research, data, experience, but they're only our own opinions. So we're both founders, and we know a lot of companies that didn't start from day one with security in mind. And so at some point, they're hiring DevSecOps. And as such, the role of the DevSecOps is to actually go over the code and do a threat analysis, determine what are the risks that the company is taking, and then pick up some tools in order to mitigate all those risks and to detect vulnerabilities. Now, there are a few questions. First of all, you need to think about the different layers of your application, what are the risks. And once you do that, you need to pick up the tools. But the question is how you will pick up the tools knowing that you have a project or multiple projects with multiple frameworks, languages, infrastructure that is becoming more and more complex. So this is what we want to talk about. How do you actually pick those tools?
Yes.
Luke?
So we're going to use what we have up on the screen is kind of like a sample project. We're not going to show a lot of detail about it, but just want to provide a little bit of context. So you don't have, actually, how many Java engineers or programmers are in the room? Okay, cool. So if you have a Java application, it's probably not just Java, right? You probably have some Python in there, some Bash. Now you've got Terraform, HCL files. You've got Docker containers somewhere. So there's all these different layers. Maybe you've got TypeScript, JavaScript. So there's going to be broad, basically there's a lot of breadth that you're going to have to cover. So we have this kind of just sample app to show you, and we'll use that as kind of our fictional toy project. So kind of run the show. We'll go over the 5 categories of tools to consider. There's probably more than 5, but these are the 5 that David and I think are kind of like the big ones to start with. From there, we'll talk about how we would evaluate an open source security tool. So what are some of the criteria and the things that you can try on your own? For any recommendation that we make, you should go try the tools yourself and play with them. So the first-hand experience is going to be big. We'll make our recommendations. And then we'll talk about some of the challenges of using open source tools, particularly as you try to scale a security program. And we'll discuss how to leverage them. So think about metrics and things of that nature. And we'll leave time at the end for questions.
Right, let's go.
Cool. So the 5 categories. We're going to start off with code scanning. So this is known as static application security testing, or secrets. And we'll talk about more what each category means once we get to it. Dependency checkers. So it turns out that for a modern application, the tip of the iceberg is the code that you write at your company or for that project, and then you have a massive, under-the-water amount of dependencies. It's like 90 to 99% of a code base is the dependencies that you're using. It's called software composition analysis. We'll talk about infrastructure as code. So as we start to move towards everything living in code, includes infrastructure and resources, you need to scan that. You're probably running this now. Maybe you have microservices. You've got a Kubernetes cluster somewhere. So you've got containers. How do you ensure that those containers are secure? And then once you get past more of the static source code side of things, actually getting into runtime scanning. So your application is running, and we're going to dynamically test it. When we think about how to evaluate open source security tools, these are the 4 kind of high-level categories. So result quality, kind of are the results good? What's the experience of using that tool? Not only for folks on the security side, but also the software engineering side. How mature is the tool? So our preference is generally going to be towards tools that are more mature, that have commercial support, things like that. And then the biggest one is going to be customizability as well. So can you actually tailor these tools to work for you? Because I'm sure you do something special at your company or on your project that nobody else does. We see that time and time again, so you got to be able to customize. Okay, so we're going to dive into result quality. When I say result quality, and because we're talking about really open source tools that your developers should know about, we're going to focus on the developer perception of the results. So one of the big things that I've seen is in the industry when we talk about code scanning, We talk a lot about true positives, false positives, true negatives, false negatives, all that stuff. At the end of the day, I'm going to claim or assert that a true positive is anything that the developer actually agrees to. So it's not like, is it technically true, but does someone actually want to go make a change because of what they've seen? And that's going to be, that's a high bar, but that's one that we're going to hold ourselves to. Google, by the way, has done a really nice job of this. They have a paper about tricorder, and they talk a little bit about this philosophy. So that's published online. I recommend it. You should validate the tools for result quality on your own code. So there's a lot of known vulnerable repos out there. JuShop is one of them. Use those repos. They're good starting places, but try to actually go run this on your code, and then actually compare results between tools. So that's how we'll figure out the result quality.
The second criteria that is one of my favorites, being also a previous software engineer, is developer experience. It's usually a topic that is not top of mind for security guys, security people that pick the tools, because they're usually more focusing on result quality than on what's the experience and what's the impact on the developers that need to use these tools. And so one of the first criteria here to take into account is the fact that the tool can run anywhere. It can run in your terminal because usually you want to test it first, and it can run in your IDE because that's even better than running your CI. You can catch vulnerabilities at the earlier stage, like you were all talking about the shift left trend. So catching vulnerabilities in your IDE is actually the best thing you can do as a developer. And of course, it needs to be well integrated in your CI/CD. So a lot of tools that we'll show here can be integrated easily. For example, they're releasing some GitHub Actions that you can use directly into your CI/CD without having to do extra work, and that's good enough to start with. Of course, you want those tools to be fast. No one wants to wait hours in the pull request for the tools to run, because that will highly impact velocity. And of course, there's also the balance between being the most secure possible, and on the other hand, not hurting velocity. But as a developer, it's really important not to adopt tools that at some point really hurt the velocity of your team, because the guy who will pick those tools will be hated by the whole engineering team.
And the thing to do there is the tool has to be faster than the tests that run on that project. So if you can run a security tool faster than the developer's tests, that's usually like you're good to go.
Yeah,
so it just can't be the slowest thing.
Exactly. The results need to be human readable, because, of course, when you want to test the tools, you want to be able to understand exactly the results. So, JSON format or something like that you can easily read. And of course, it needs to be machine consumable, because, as I said, you want to be able to install that, integrate that in your CI/CD pipeline. And so you want to be able to automate and program against the results of the tools. And so that's really important. And at the end, run the tool yourself before you introduce that in your pipeline, and make sure that it works correctly with all the different things we talked about.
Cool. On the maturity side, we're going to look at the level of support a tool has. Is it active? Is it stable? Basic things to look for: popularity. So if you're looking on GitHub, does it have stars, forks, watchers? Is there a commercial entity behind it, or even a nonprofit? So some of the tools that we'll talk about are supported by OWASP. Others have commercial companies behind them. And then check the licensing. So there are some tools that you can run on. They're commercial tools you can run on open source projects and public code, but you can't run them on your private code. So we won't consider them here today. Check the licensing. Make sure you know what the fine print is. And then finally, on the customizability, I was speaking with a teacher the other day who introduced me to this idea of the reusability paradox. Has anyone heard of the reusability paradox before? Cool. It's new to me. So the more generalized something is, the less utility it has. So if you're using one of these tools off the shelf, these tools are meant for many different types of people, companies, and projects to use. So they have necessarily lower utility. They're trying to catch the kind of lowest common denominator types of issues. For you, again, this goes into, we want it to be really high utility, so it's got to be specific to you. So how do you tailor? Maybe you use authentication in some special way, or I'll use that as the example. So we want things that can be tailored. And then Beyond that, there's going to be some things around what files does it run on, what types of projects, what is its behavior, does it block a build, does it just notify the developer? And so that gets into the configurability side of things. OK, everyone still with us? We're going to dive into actual recommendations. Sweet. So on the code scanner side, code scanning very broadly is scanning the code that you write. So this is also known as static application security testing. Very commonly, these types of tools are going to check for OWASP top 10 issues, CWE top 25 issues, secrets, and then we talked about some of the custom rule ideas. If we're doing this well, if a tool is really working well, it's going to make it easier to write secure software, and it's going to make it faster to do so. You can kind of think about these tools as an automated code review, right? So during a code review, we want to just leave a comment or leave a little note for the developer. Hey, here's the issue. Here's the context. Here's how you would fix it.
Yeah, just a side comment here. We added secret in this category like SAST because at the end, usually it's considered as something separate or dedicated section. But at the end, it's just SAST. Just you're looking for specific regex expressions. It's just plain SAST.
Yeah. So this is our kind of grouping for the code that you've written, and so secrets falls into that. And SAST as a field has been around for a long time. It's a field of program analysis and static analysis. So there's a lot of tools out there. A couple examples: if you're in the Java space, you probably use Spotbugs. Rubocop is for Ruby. Bandit is for Python. And then you have secret-specific tools like Git leaks or Git secrets. So these tools will come with a lot of checks out of the box. The issue, if you go back to that sample project we had at the very beginning of the talk, it's a multilingual project, right? So if I want to adopt these tools, I would be adopting probably multiple of them, right? Maybe I have Python, so I've got to get Bandit in there. Maybe I have Terraform stuff, so I have to add a Terraform tool. So for that reason, kind of the recommendation of this group, and I do acknowledge my bias as a maintainer of Semgrep, is Semgrep. But I'm going to try to explain why, and you should use all these tools. The first, on the result quality side, is that it's going to come with many thousands of checks to run out of the box, and this is across 30-plus languages. So of all of the contenders that I showed you, this is the tool where you can choose one tool, you can have one interface, but you can now scan Java, JavaScript, TypeScript, Python, Rust, Docker files, everything from just one tool.
As you can see here, it also supports secrets with Git leaks.
It does,
These are
yeah.
just specific rules.
So this is the thing where, because it's an open source tool and rules are simple to write for the community, actually a number of what I showed on the previous slide, a number of these other tools have been ported to Semgrep. So you can get Git leaks, FindSec bugs, GoStack. And this tool is actually the underlying engine for GitLab's code security offering. So you may already be running this, and they chose this tool to standardize on because they could have one tool instead of trying to manage 15 or so individual ones. So just an example of Git leaks, we want to show you what these tools look like to run. So you can invoke this on the command line. You just run semgrep. We're going to run it with the Git leaks checks. And in your source code, it would identify where you have maybe an instance of a token that you're leaking.
Just trying to highlight the importance of using only one tool for your SAST capabilities. Try to imagine now if you had all those different tools like Git leaks and GoSec and all those different tools, and then you need to maintain them, meaning that every time there's a new version, you need also to upgrade your tools, making sure things are not breaking. Having only one tool, you only need to deal with upgrading this tool, and the team is actually doing all the hard work behind the scenes.
Cool. So on the developer experience side, this runs everywhere. You run in the command line, CI/CD, Docker, your editor. It's super fast. So I think across last year there were 30 million scans of projects with Semgrep. For an entire project, I think median time was 20 seconds to scan. And it's faster, obviously, when you're on a single file or smaller section. Super extensible. And the big piece for this one is the customizability. You can write your own rules. So if you can program in a language, Java, Ruby, other, you can write your own rule, basically just copying and pasting the code you want to match, and that becomes your pattern. So this is really just a very powerful and fast code search engine. So I have an example of, this is actually one that we use within my group and company, but you can't have console.logs. So the pattern is literally just console.log, and there's some kind of regex-like things that you can do to generalize that pattern. And that leaves a message for the developer. Quite popular, so this actually started at Facebook. I think it's a 9-year-old project at this point. Docker pulls, there's over 12 million Docker pulls, 179 contributors, and a lot of rules, so it hits that for us. And that's Semgrep in a nutshell. We'll kick it over to dependencies.
Awesome. So let's talk a little bit about dependencies. As Luke said before, if you're doing your job and you're a good developer, you probably want to look for libraries before trying to re-implement and reinvent the wheel. And so there is a lot of libraries out there, and even if your code is the most secure in the world, well, maybe your libraries aren't. And so for that, there are a lot of tools and databases available that are actually doing the hard job of finding those vulnerabilities and put that in a publicly available database. And so this whole field about software component analysis, there's multiple players in this field. And as for SAST, most of the tools are actually specific for an ecosystem or language. So you have safety for Python, retire for JavaScript, NPM audit also for JavaScript, dependency check, the OWASP project that is mainly working for Java. And you have this newcomer, OSV, which is a project maintained by Google. It's actually, that's really the beauty of it. It actually aggregates a lot of different database and advisories together. So obviously, this is our pick, not only because it aggregates everything, but also because of the result quality. So they're curating the sources, they're making sure that the result that you get from this tool are accurate, and it supports 13 languages as of now. In terms of DevX, they also thought about the challenge of providing a unique schema for all the different languages. So that's also a win, because you don't need to have to deal with the different formats of all the different languages or different tools that you would use otherwise. For all the tools that we'll show here, it can run anywhere locally in your IDE and easily integrated in your CI. In terms of customizability, that's really interesting because you can scan very different files. You can scan your SBOM files, your log files, and you have multiple options in order to ignore some specific files and do some recursive in terms of how it runs. As you can see here, it's a project that's been created a couple of months ago, but it already collected almost 5,000 stars, so it's really the rising star in the SCA world. And so I encourage you to test it. How it runs, really easily. OSV-Scanner recursive, and this is what the results that you will get with all the different dependencies in your project and the one that have some vulnerabilities. And even it also helps you with remediation and give you some suggestions on what package you need to upgrade, what version you need to use to remove those vulnerabilities. The next category is infrastructure as code scanners. So if you're a modern company and you have some infrastructure, including infrastructure in the cloud, the best way to manage your infrastructure is to codify it. And so there are multiple languages and frameworks that support it, whether you're using the very popular Terraform to do it, especially if you want to use a public cloud like AWS, GCP, or Azure. And the problem is that it's very easy by default to misconfigure your cloud. Why? Because when you're creating some block in Terraform, there's a lot of flags that you can, and also configuration that you can do, and you may not think about it. And so even if you're expert at AWS, you may miss some of the mandatory checks. And so for that, the whole field of infrastructure as code scanning has been created, and it deals with a lot of different types of misconfiguration. The first one is making sure that you're encrypting your resources, like your databases or your S3 buckets that you're encrypting at rest. You want to make sure that you're not missing permission, you're not over-permissive. So a lot of the time, DevOps tends to provide, star in terms of your permissions, and so this is something that you want to catch really early on to prevent some really, some hackers to actually get into your infrastructure and do some permission evaluation. Logging is really important, And at the end, you want to make sure that you're not using default settings. In this category, there are a couple of contestants. Here, some of the tools are really specific to Terraform, for example, to some language. As you can see also, Semgrep ported some of the rules that are scanning for infrastructure as code. And there are also some big players like Kix and Chekhov that are actually supporting a very large number of frameworks. Here our pick is Kix for multiple reasons. First of all, it supports about 18 different frameworks and has a lot of different queries that are built in. It's maintained really on a daily basis and has a lot of tests in order to make sure that all the rules and the queries that have been implemented in the tool are really relevant and working well. In terms of DevX, it also provides some really nice recommendation and guidelines how to fix the issues. And that's really important because it saves a lot of time to developers and DevOps. Runs everywhere.
So that's one of the things that is hit or miss for open source tools. So they may find the problem, but may not tell you how to fix the problem. Yeah. So this is notable for Kix.
It runs everywhere. It's very customizable because all the queries have been written in the very popular language called Rego, which is de facto the standard to write policies today thanks to the Open Policy Agent project. And so you also have the ability to support new frameworks because the whole logic of supporting frameworks is based on some regex expressions. As you can see, the community is very large. Right now, about 1.5 million Docker pools, and community is just rising. And actually, we also were part of the contributors to this project. So really great project. This is an example of how it runs. This is an example of an EBS resource that we're creating in Terraform. And as you can see, if you have good eyes, it's not encrypted because someone mistakenly probably added a comment there, commented out the line. And so if you're running the tool Kix, very simply, very simple parameters, basically it will alert you that you have a problem and you didn't encrypt this resource. The next category is continuous scanning. So here again, if you're a modern company, you probably deal with containers, right? Who doesn't use containers today? No one, great. So you probably need to have some container scanning in your tool belt. So obviously here you want to detect vulnerabilities. Similarly to what we talked about when we talked about the libraries and the dependencies, when you are using a base image in your container, at some point you're adding your code. Your own code can be super secure, but what about the base image and the OS it comes with? So here we have a couple of contestants. You have Trivy, Claire, and Gripe. These are great open source projects. One of the problems sometimes is that they're providing inconsistent results between all the different scanners. And so I also recommend another project or another company actually called Slim that actually deals with this specific issue. But if you want to stay with the open source version, we actually recommend here Trivy. Trivy provides some great results, and also it supports scanning between container images, file system, a lot of different targets. It can also generate an SBOM, which is very relevant. If you're not following the trends, everyone wants to generate SBOM, so it does that automatically behind the scenes. In terms of DevX, that's a great thing. You don't need to have a special setup for that. It already comes with its own database, no need for external libraries or something. It can run everywhere, including in your ID as an ID plugin. And it's very customizable. Right now, you can add a lot of different modules in order to extend and add your own detection logic, and even some plugins to extend the CLI. Very, very, very popular, as you can see from the 60 million downloads in Docker. How to run it? As you can see here, we want to scan the public image of WordPress. Very simple command line. And this is the results. Well, actually, parts of the results. Probably if you are using WordPress, you know that there are quite some vulnerabilities there. And finally, runtime scanning. Why do we need runtime scanning? Well, because you cannot detect everything only using static analysis. And so runtime scanning here, I'm talking specifically about your application, not about your infrastructure, and you also need to do some scanning there. But here, let's talk for a minute about your application. So this is the whole field called DAST, Dynamic Application Security Testing, and there are a lot of different projects that are open source in this field. You have ZAP, Nikto, Wapiti, and Arachne. Here, by far, the popularity of ZAP, a project that is also part of OWASP, is like there's really no way to compare to the other projects. Why is it so popular? Well, let's see. First of all, in terms of history, that's interesting. It was built in order to detect specifically the OWASP top 10 risks. And so over the years, they actually added more and more and more rules, and now they have about 250 created rules. In terms of DevX, it provides both a very simple experience to start with the desktop application, but, and that's important, if you want to be able to integrate that in your CI/CD, because you want to be able to scan your application while you're deploying that on staging and not on production or before production. So they also have a headless mode with their Docker version. In terms of customizability, a lot of extensions available. They have a full marketplace for it. And as you can see, it's a super, super popular project. The GitHub top 1,000 projects, so you can imagine that a lot of people are actually watching this project. The way to run it, and this is the way to run it in your CI/CD, because it's headless. And this is the results that you can get, and you can have all the alerts that you need for your different URLs in your application.
Cool. So we covered a lot of territory. We're definitely going to have time at the end for questions. Quick recap, the 5 tools are Semgrep, OSV-Scanner, Kix, Trivy, and Zap. And the big recommendation is, we probably presented 20 tools today.
Yeah.
Obviously, we don't have time to go into depth on every single one and the pros and cons, but I would definitely play around and see which tools work best for you and your environment with your development practices and for the issues that you want to find. But these are our starter set.
And we'd be happy to talk with everyone that feels otherwise, that
Yeah.
our suggestions are the best one. We won't take it personally, for sure.
Cool. So quick recap, we've covered the 5 categories, talked about how to evaluate the tools, provide our recommendations. Now we're going to go into how to actually leverage these tools and scale out your security program.
Awesome. All right.
Yeah. So one of the interesting things when I talk with teams is that they want to deploy across everything quickly. So like all projects have to have this new security control. And maybe this is like the startup iterative person in me. It always makes me nervous because I want to prove that this is actually going to work within a company or for a set of developers. So for me, what I would push for instead of don't try to solve the problem everywhere to start, but pick a development team and start small in scope day one. So I know, I think it's more common now to have security heroes or security champions. So these are software engineers who are more security inclined. Picking a team that has one of those individuals or multiple.
Yeah, as a security practitioner, you may think that it's really easy to implement and add and integrate those tools in your CI/CD pipeline. So you may be tempted to actually do the whole thing at once. Like take the whole the 5 tools that we have shown here and add them on day one in your organization. Don't do that.
Yeah, start small. And an interesting piece for this is don't start blocking. So when you first deploy these tools, if you can, make them informational and more educational, right? So we're trying to avoid basically putting a red X on a build to start, because we don't know if the tools are going to be performant. We don't know the types of issues they're going to find day after day. So this is a chance to kind of get some reps underneath and try to be helpful to the software team that you're working with. And during that process, that's the time where you're going to get feedback. You're going to tune it. So as an example, for tools that I've seen, a big part of the process is actually choosing what you don't want to scan, right? So like what are the files and things you want to ignore? Maybe you don't care about security issues in your test code, as an example. Okay, let's add the test file to kind of our ignore list. So things like that, it's going to take a little while to figure out and get it right. And then when you're running all these tools, there's the kind of qualitative aspect of this. So it's the feedback that you're getting. But then what's the quantitative? How do you show that the tool is actually working? This is where we encourage you to decide on a few key performance indicators for your program, kind of for the experiment, and make decisions based off of that. So how fast are these tools? One example is I've been told, someone came and said, hey, we're getting reports from our developers, this is for Semgrep, it's too slow. It's taking way too much time. But then when we reviewed the data that we had collected, it's like 5 seconds on average, and 99% of the time, that's how fast it is. It was actually like incredibly fast, not a problem. So qualitatively, we're getting reports it's slow, but quantitatively, we can show that, hey, actually, this isn't a problem for the organization. So things like that. And then we're also going to look at some other indicators on results and if people are actually fixing things, but encourage you to have some KPIs.
Yeah. Want to talk about the KPIs now?
Oh, yeah.
Afterwards.
Oh, we did it.
Yeah.
We did it. So we picked 5 tools. We saved the city. This is amazing.
Right.
So congratulations, everyone. This is great. You've chosen a tool. You've rolled it out. You've got your KPIs. And that's the beginning of the story. But it's not quite the end of the story. And this is where, in order to actually do this at scale, there are some challenges that you will hit and have to work around with open source tools.
So what are the challenges? The first one is that, well, basically, you have probably multiple repositories, multiple microservices, and so what you want to do is to be able to roll out all your tools to all your to all your repositories, and so you want the ability to scale in terms of rollout. In terms of coverage, you want to be able to monitor as much resources as possible.
And this becomes pretty intractable around 3 projects, I would say. So if you've got 1 project, 2 project, you're adding these tools, you can keep track of it. Once you get past the 3 mark, suddenly it's how do you track success, failure, scan times, the results that you get. So you're going to start to need some infrastructure around the tooling.
Yeah, also integrating some tool in your CI/CD when you have 1 repo is quite easy. You just add a file and that's it. But what about when you have 100 repos? So recently, GitHub added this nice feature about the centralized pipeline that you can run, and that's a way you can do that more easily. But it's still a challenge because sometimes you may want to configure your pipelines differently depending on the repository. So that's usually one of the challenges that you need to take into account when you want to roll out to multiple projects. The second is, as you may guess, each tool has a different output. And so on one hand, you want to be able to get all the results back to the developer in a consistent way. On the other, you have to struggle with the difference between all the tools, because each developer or each maintainer of the tool thought a little bit differently about the experience. Whether you get the results directly as a comment in your PR, or as an artifact in GitHub, for example, or as, I don't know, an issue in GitHub. There's multiple ways you can get the results. And so that's important to know how you can achieve consistent behavior, because you don't want to have a high learning curve for all those tools. The next challenge, and we talked a little bit about it before, is how do you manage upgrades? All these tools have its own life cycle. Sometimes they get a new version every week, every month. How do you deal with that? How do you test that the new version is not breaking everything? How do you know exactly if you need to do some changes in your pipeline, that there's no new feature? That's really a headache. The next challenge is about the difference between handling your backlog and preventing new issues. So the first day that you're adding all your tools and the DevSecOps is now doing its job, you may think about 2 different strategies. One would be to start dealing with all the existing issues at once. And the second would be to differentiate between your existing issues, your backlog, and the new issues. I always like to take this example of a boat where you have a hole in the boat. And so there's water coming in all the time. Now, what would you do in order to make sure that you're not sinking with the boat? Well, I'm sure that if you're thinking in terms of logic, probably the first thing that you want to do is to clog the hole, right? You don't want to start removing all the water from the boat because you will have new water coming in all the time. So the same thing here. The first thing you want to do is to deal with the new issues. And how to do that? Well, basically, you add all your tools in your CI/CD. You're doing that in a blocking way. And then once you deal in a daily basis about your new issues that you're entering and making sure they're not part of your existing backlog, then you can have a dedicated effort to deal with it. And finally, and we talked a little bit about that in terms of remediation, because they're open source tool, the guidance is not all the time tailored to what you need. Sometimes, and most of the time, the tools are not giving you all what you want in terms of remediation. There's sometimes only a link to documentation. You need to deal with that.
Yeah, so we share this not, basically like not to maybe put down any of these tools. This is the place you should start. You should start with open source tools. I think it's more to try to kind of show you, hey, as you go down this path, and if you're going to try to use these across your entire organization, where might the obstacles be? So open source tools are a great starting place. There's just going to be work you have to do afterwards to actually scale their usage across all your projects.
Great. Let's talk also a little bit more about the KPIs.
I think we have like a couple minutes before we...
Yeah, about 2 minutes. Because there are three interesting KPIs that you can think about. The first one is security detection rate. And why it's important, we talked about the fact that you only want to add blocking PRs or blocking your PR with the tools once you're ready. So one way to do that is by measuring your detection rate. The second is basically making sure that you're measuring all the time the mean time to resolve. And here you want to be able to separate between pre-production, so basically your PR or your staging, and what's happening in production, where usually you have an MTTR that is bigger because you have to deal with existing issues. And the final KPI that is interesting to follow in order to measure the success of your DevSecOps program is basically the exposure window, which measures how much time all your vulnerabilities are in the wild and can be exploited.
So these types of things to track, two kind of ways to go about it. One is, we talked about machine-readable output. So you can go and actually gather all the JSON from all the tools, pipe it into your own dashboard, your own database. Again, this is like more building out your infrastructure. Or this is the realm of vendors, right? So there are a number of people, Jit included, right, who are building this type of capability.
And beyond those KPIs, if you're interested to know a little bit more about how to orchestrate all the tools, how to deal with all the challenges that we've just shown for all these open source tools and beyond, I encourage you to visit g.io, which is our product.
Awesome.
And look.
And on the Semgrep side, it is an open source project. You're going to get a ton of value out of using the open source thing. That's where 99% of people start. We have a commercial offering on top of it, which is starting to get into, hey, what are the things you really need to look for to operationalize this for your company and your scale? So you can check out the link there.
Awesome. Thank you, everyone.
Yeah, thank you.
There's a time for questions.
Yeah, so we have time for questions. We love hard questions, so I think we are meant to use the microphones, and we'd love to chat.
Yeah, thanks. This is great information. I was wondering if you could go a little bit more detail on the, right there at the end, one of the metrics, the exposure window. Is that while the vulnerability is live in production?
Yeah, basically we're talking about vulnerabilities that are in production, that you know about them. And so it's important to track how many of them are in production and for how long.
Thank you. Any other questions? Oh, yeah, we go.
For SCA tools, one of the issues that we ran into in testing those is the inconsistency of open source software names. So I was wondering, as you tested, was that something that you ran into? And if so, how did you address that when trying to compare tools and outputs?
Interesting. Where does the inconsistency come from? In the, like, or do you have an example?
Yeah, so like I think you listed Trivy and Gripe. We noticed a lot of times some of the tools would use, I think NIST recommendation for open source software is that you use the name provided by like the vendor or the creator, but sometimes people would use the names like say the GitHub repository or the file name. Yeah. So just the inconsistency.
This is basically one of the challenges with open source tools, and that's why sometimes you need some vendor that is actually taking into account those inconsistencies and try to resolve them. Yeah. I
Thank
agree.
you.
In terms of remediation of the issues, do these tools provide prioritization in order to address these issues?
They do, yeah. So generally, you'll have something like low, medium, high, critical that's assessed to it. Or in the case of reported vulnerabilities, right, you'll have what's the CWSS score?
Yeah.
So you'll actually have a score that's put to it. I think the problem is, for a lot of the tools, if you're looking in the SAST space, the severity of the issue is probably judged by either the author of the rule, the person who wrote the check, or the tool. So there is inconsistency between tools. So that's where you have to look at, hey, what's the kind of philosophy of that particular tool and that particular program? So there's inconsistency in the SAST space, and for the CVE reported vulnerability space, there's more consistency. The CVSS score, I think, has a couple components it takes into account, and that's published alongside of the CVE.
And I would add to that it's not enough to look at the CVSS score, for example, to prioritize and triage between your different vulnerabilities, because how do you deal with differences between code vulnerability and infrastructure vulnerability? Everyone says it's high, but how do you compare those different high vulnerabilities? So for that, you need also to take that into account, making sure, for example, that you're tagging your repositories to know exactly which one are critical assets and which are not. And based on that, you're actually doing your triage.
TJ Reed, Department of Conservation, great presentation. We're starting our journey down to securing our applications. But one of the things that I wanted to ask to follow up that the other gentleman said, do any of these KPIs or tools tie to money saved?
So that's a great point. Not when you're looking at open source tools, because usually they're not thinking about business or anything. But a lot of vendors that aggregates the data and orchestrates like what we're doing, we're also trying to convert that at some point to dollars saved. Because if you're thinking about fixing those issues as early as possible, you're actually saving a lot of time ahead versus not doing that and had to deal with that in production.
Yeah, so I've played around with something like this, where we'll look at how many issues, for instance, were fixed by developers, rather than later in the process by a security engineer opening a ticket, going through that whole process. So you can get estimates, but you'd have to play with the math. Like, how much time do you think it takes? 8 minutes, 10 minutes, and then you can go from there.
Thank you very much. What is the score in the OWASP benchmark for your tool, the commercial and the open source? And what are the limitations to achieve a 100% score?
Yeah, that's a great question. I actually, totally candid, I don't know what the benchmark score is. I know we have run the benchmark, as have other people who use the open source tool. What I can do is speak to limitations, particularly for the open source tool. So I mentioned it's super fast on the Semgrep side. One of the reasons why it's so fast is because it's scanning an individual file at a time. So what we found is that's really, really good if you want to enforce what we call guardrails or secure defaults. Example would be, you can't use raw SQL queries here. You have to use an object relational mapper, which is going to completely eliminate a class of SQL injection bugs. So it's kind of like secure by design. That's something that you can check for within one file, because we see a raw SQL string. We don't do that, right? So it's kind of binary. On the commercial side, what we found is for vulnerability detection, there are often vulnerabilities that will require context from multiple files, right? So user input enters at an API site, call site, that trickles down. And so that's what we address with the commercial side. And that's really like the biggest difference, yeah. So sorry I don't have the score handy, but I'm happy to chat after.
So when you get all these reports with all the vulnerabilities that come out of, say, your SAST or your DAST, do you have recommendations for how you visualize those for remediation, how you can tie those together? Because I might let the fact that there's a static password in the code, it might just be a dumb default because it gets taken care of in runtime, so I can mark it. Do you have recommendations in the open source space for managing that?
So I think there is a project in OWASP, if I'm not mistaken, I think that it's actually, this is the goal, like having some kind of vulnerability management project. It's nice, but it has its limitation.
So the project is called Defect Dojo.
Yeah.
I work with folks who use it, and what it requires, it has a bunch of integrations, so it knows the output of these different tools, and you can upload them. That'll give you one place to look at stuff. I think hit or miss. I don't have a sense of kind of at what scale, like for the organizations who are using it, how big are they? And I have more people that I can think of who have built their own system. So they'll pump everything into like a Snowflake database, and then they'll use the visualization tools on top of Snowflake to track this kind of thing. But again, that's cost. That's now infrastructure you have to maintain. So it just depends on your resources.
Or you're using a vendor that's actually doing that.
Yeah, and there are more and more vendors now who are trying to be the central place for kind of all security tools and results.
Awesome. I think that's it. Thank you again.
Yeah, thank you, everyone. Appreciate it.